Japan Testing Center for Construction Materials, or JTCCM, was inaugurated in 1967 in Soka City, Saitama Prefecture, as one of the representative third-party testing institutions in Japan. This place is well known as an historic site, with a monument erected in commemoration of a poet of ancient Japan. Soka City is also famous for its rice cracker production, which is known as Soka Senbei. Within a close proximity of 15 kilometers from central Tokyo, we have experienced several significant achievements over our half-century in this area. Allow us to share some of our noteworthy features and technology. First, a brief history of the Central Test Laboratory. We started in 1963 as a third-party accreditation organization for testing, research and standardization for construction materials. And we have expanded this business to cities across Japan, from Sendai in the north and Fukuoka in the south, to provide a wide variety of services to customers. Among the various services, the Central Test Laboratory conducts quality assurance testing to verify quality requirements for materials and components used for buildings and civil engineering structures, thus playing a vital role dedicated to the social infrastructure. There are several features of which we are particularly proud. One is that we conduct fair and highly reliable testing, the reason why we have been highly evaluated and trusted by our customers for such a long time as a third-party testing institution. The second is that we offer a wide variety of testing options on our menu. We not only respond to customers with versatile requirements, but offer one-stop solutions through a quick response system and keen partnerships and cooperation with 4 specialized testing areas of materials, structure, fire resistance and environment. And the third is our reinforced testing facilities. As we have been required to conduct tests of larger and more diverse cases in recent years, we added a structural testing building and dynamic wind load testing building to meet testing requirements on an even greater scale. Finally, it's about our skilled and experienced staff of engineers. They do their best to provide high-quality service by studying at various in-house training classes and for obtaining higher professional qualifications and academic presentations. Next, let us guide you through our testing scenes, from the structural group, the environmental group, the material group, then finally to the fire resistance group. The structural group deals with strengthening tests on large-size construction materials, components and joint components. In October 2016, we completed a new testing site, twice the size of the original one, and it has been in operation since April 2017. We will introduce various strength tests on main structural members. The large-scale lateral loading system under axial load is used for structural members, joint components and frames applied to large-size buildings, such as reinforced concrete structures. A maximum of 5,000 kilonewtons in a vertical direction and 2,000 kilonewtons in a horizontal direction are capable of loads. For shearing tests of bearing walls over 3.3 meters in height, a lateral load testing system is used. It allows performance up to a height of 8 meters and a width of 6 meters. The horizontal load allows a maximum of 500 kilonewtons with static tests, while the dynamic tests allow up to 100 kilonewtons. A strength test on 2-story type of test specimens is performed using the structural reaction wall and floor. The structural reaction floors occupy an area of 13 meters by 8 meters. It can assemble a reaction walls for various requirements by clients. A testing system for wooden structures is used for shearing tests of wooden bearing walls requiring government certification. This testing system, due to its 3-dimensional structure frame, can be extensively used for horizontal pressure tests on ceiling units for compliance with technical standards on ceiling poles or handrails. A bending test of full-scale beam members, roofs, floors and wall panels is performed with a 500 kN bending test machine or 1000 kN structural test machine. The loading equipment houses a universal testing function so that it allows tensile tests on joint components and others. A 500 kN fatigue testing machine is used for confirmation of fatigue properties such as tensile fatigue tests on steel bar joints or bend fatigue tests. It can also be applied to repetitive fatigue tests on dampers and various joint components. A strength test on wooden materials and high polymer materials is performed in the constant temperature and humidity room, allowing standard conditions of temperature and humidity. A long-term load test can be performed on wooden materials as specified in the Building Standards Law. Next, we will show you various safety confirmation tests for non-structural parts. A swinging pendulum impact test is performed in the shot bag testing frame for glass on the walls or adhesive films for window glazings of buildings. The lateral load testing system is used for a diagonal deformation test of non-bearing walls, including external walls and partitions walls. It can also conduct lateral dynamic tests in consideration of earthquake waves. A horizontal shaking table testing machine is used to test for confirmation of vibration characteristics and seismic resistance properties for raised access floors, furniture and facilities. It also performs shaking table tests in a horizontal direction at a maximum acceleration of 1 g by applying sine waves or earthquake waves. A diagonal deformation test of the JIS compliant adhesive films for glazings and an in-plane displacement trackability test on door sets are performed by using a diagonal deformation testing frame for plate glass. It also performs horizontal load tests on handrails and guard fences. A swinging pendulum test of the JIS compliant door sets and panels is performed by using a testing frame for door sets. It also performs ball falling impact tests and strength tests on door sets. The environmental group conducts tests on external natural environmental factors such as rain and wind, as well as indoor environmental issues such as heat, moisture, light and sound. In October 2016, we also built a new facility that allows tests with a natural external environment of wind and rain, thus allowing us to perform dynamic wind pressure tests with larger size test pieces than previously, as well as tests with actual winds. Let's start with the dynamic wind pressure tests on rain and wind. The dynamic wind pressure system is used for tests for air permeability, water tightness, and wind resistance of building envelopes such as roofs, walls, windows, and door sets. A test piece of a maximum of 4 meters in height and 5 meters in width can be tested. A maximum of 10,000 pascals of load pressure will be applied, and the spray volume will be 2 to 6 liters per square meter per minute. Tests for water tightness and wind resistance are performed for actual winds over roofs, walls, building fixtures, solar light modules and fences using the wind and rain blowing simulator. This equipment can reproduce 3 different types of wind: steady, pulse and gust, with wind speeds that can range from 3 to 66 meters per second. The spray volume is 2 to 6 liters per square meter per minute. Next are the tests on ventilation equipment and fire preventive equipment. For ventilation equipment such as exhaust fans and ventilation louvers, a ventilation property test is performed to measure the amount of ventilation by adding a constant pressure differential to both sides of a specimen. For fire preventive equipment to be installed at a wind tunnel or a fire damper, tests are conducted to confirm the air leak amount at time of a constant pressure differential, and an operational status of the thermal fuse at the time of a specified temperature. For large-size fire prevention equipment, like fire prevention doors or fire prevention shutters, the dynamic wind pressure system is used to measure the smoke insulation properties. Next are the tests for heat, moisture and light. Thermal resistance and dew condensation tests of building fixtures and external walls are conducted at the environmental test rooms of dual type to recreate the temperature and humidity environment both outside and inside the room. We have 3 environmental test rooms of dual type that are capable of controlling the temperature and humidity at a range of -20 degrees to 40 degrees Celsius in temperature and 40% to 90% of relative humidity. They can offer tests for a variety of temperature and humidity environments. They are also capable of testing for large-size fixtures over 2 meters high. Thermal distortion and durability tests of exterior materials of buildings are performed in the artificial climate rooms. This room is also identical with the environmental test rooms of dual type, allowing temperature settings from a range of -20 degrees to 40 degrees Celsius and 40% to 90% relative humidity. The outdoor chamber is equipped with infrared light and water spray nozzles, equipment enabling the solar beam equivalent heat and extreme changes of temperatures. A shading coefficient test for shading devices is conducted by using a light source capable of irradiating the solar light equivalent beams called the solar simulator. These are tests compliant with JSTM or JTCCM standard of testing methods enacted in 1995. This is a physical property test for heat, moisture and light environment. A thermal property test room is used for thermal property tests of the construction materials such as thermal conductivity, specific heat and coefficients of linear expansion. Among these thermal property tests are performed with 2 sets of instruments for the guarded hot plate method and 5 sets of instruments for the heat flow meter method, allowing for measurements at various temperatures and thickness of test pieces. Calibration test services are conducted here, as it is the only existing institution for thermal conductivity calibration in Japan. The moisture property test of water vapor transmission, water vapor permeance, and hygroscopic sorption properties for general construction materials is performed in the moisture property testing room, which maintains specific environmental values of temperature at 23 degrees Celsius and relative humidity at 50%. In addition, as related to moisture, a test of water vapor absorption and desorption properties is performed as well. An optical property test is performed on flat glass, window glass film and paint to measure reflectance and transmittance, emissivity and heat gain coefficients, using 2 kinds of spectrophotometers that are capable of measuring the wavelength range of solar radiation and far infrared radiation. Now let us introduce tests for sound. A performance test of sound transmission loss is conducted by using 2 adjacent reverberation rooms. Sound is generated by a speaker in the sound source room so that sound emanates from various angles toward the specimen. The specimen vibrates from incidental sound, and the sound is radiated to the sound receiving room to the rear. Then the transmittance of the sound is measured based on the energy density of the sound in the sound source room and the sound receiving room at that time. In addition, in the performance test of sound absorption coefficient by the reverberation chamber method, we set the specimen in the reverberation room and measure reverberation time. Then the sound absorption coefficient of the specimen is calculated from the difference in the reverberation time which has been measured under each condition with or without the specimen in the reverberation room. A test for reduction of transmitted impact sound by floor coverings is performed by using a sound source room and a sound receiving room of the solid standard floor and walls of reinforced concrete cast together. Impact is then applied to the specimen constructed on standard concrete floor according to the impulsive force characteristics of standard heavy impact sound source on the sound source room side, and the floor impact sound level is measured on the sound receiving room side to calculate the amount of reduction. The material group is compatible with various building materials, ranging from mortar and concrete materials to polymeric materials, furniture and fitting. In addition to JIS, or Japan Industrial Standards, we are also testing compliance with specifications such as NEXCO, or Nippon Expressway Companies, Urban Renaissance Agency, the Architectural Institute of Japan, and others. First of all, we will introduce tests for inorganic materials. The mortar test is conducted as quality control of cement, mixing mortar, admixture, which are the materials of concrete, and a physical property check of mortar for repair and mortar for finishing. The bond performance test between the concrete and reinforcing bar is a test to check bond performance by pulling out the reinforcing bars cast in the concrete. The freezing and thawing test is designed to repeatedly apply freezing and melting actions of water to concrete and examines deterioration conditions. The compression strength test of stones is a test to examine the compressive strength of stone used for finishing materials and rough quarry stone using a compression testing machine. The board bending test is designed to check bending strength of boards used in the interior and exterior of houses. A universal testing machine is used for this test. In the test for resistance to repeated opening and closing of doors, the test is performed to measure opening and closing resistance after a specified number of repetitions and to confirm the opening and closing movement. The next is about tests for organic materials. In the strength test of polymer materials, we use an electromechanical universal material testing machine because the target materials are diverse and small load measurement is required. Further, by using it in combination with a temperature chamber, it is possible to conduct a strength test in low and high temperature environments. The finishing material fatigue testing machine is used to examine the trackability performance of finishing materials and waterproof materials against the deformation of the base repeatedly caused by temperature change and vibration. The fungus resistance test is designed to investigate hypha growth by inoculating fungi on interior materials and the like. For fungal-prone materials, measures such as using antifungal agents are required. The slipperiness test is a test that indicates the slipperiness of products used for floors and sidewalks in numerical values. Usually a slipperiness testing machine is used, and surface conditions of the specimens can be tested by changing conditions such as dry and wet. Lastly, let us talk about a test related to material analysis. This is a test to examine what elements are included and their corresponding amount in materials such as slag and glass beads. This inductively coupled plasma, or ICP, emission spectroscopic analysis, is an analytical method that can quantify several kinds of elements at a time, separating the light emitted by spraying into high temperature plasma, thus testing qualitative analysis from the wavelength and quantitative analysis from the wave intensity. The determination of the emission of formaldehyde is a test to measure formaldehyde emitted from interior materials and their adhesives. There are two kinds of test methods, the desiccator method and the small chamber method, used depending on the target materials. In the material group, we also conduct various tests targeting both inorganic and organic materials. As a designated performance evaluation institution based on the Building Standards Law, the Fire Resistance Group tests and evaluates a variety of fire prevention issues related to structures, facilities, methods, and materials. We also conduct flame spreading tests on fire-resistant materials and tunnel repair materials such as building facilities. First, we will introduce tests on fire-resistant structures. These test results are mainly used for performance evaluation concerning fire resistance and semi-fire resistance performance. fireproof performance, flame interception performance of pipes and fire doors, penetrating walls and fire doors. Using a vertical furnace, a fire resistance test can be performed by heating vertical materials of non-supportive loads that constitute fire prevention zones, such as non-load bearing walls, backstop and fire doors, as well as pipes and cables penetrating walls. Using a vertical furnace with loading device, a fire resistance test can be performed by heating while loading the load-bearing walls of various wood structures and steel structures. In the fire-resistant tests of pillar, heat can be applied while placing a vertical load on the wooden and steel pillars of various structures, or synthetic pillars, including walls. The fire resistance tests using a horizontal furnace can be carried out by heating under loading the comprehensive horizontal materials, such as beams, floors and roofs of various structures. This test is an external fire exposure for roofs. In this test, it allows us to check the fire expansion and integrity of roofing against spot fire. The test results are mainly used to evaluate the performance of roofing, assuming urban area fires and so on. Lastly, in the heat release test, it is possible to check the combustion properties of wallpaper, film and boards that are subject to restrictions on interior finish. The test results are mainly used for evaluating the performance of incombustible, quasi-incombustible and fire-resistant properties of building materials. We have mainly introduced our focus on testing, but we are also engaging in a variety of other roles, such as technical assessment, performance evaluation tests, and product certification tests. Technical assessment is a task that takes full advantage of the experience, engineering capability, and fairness as our third-party central test laboratory. Here we achieve comprehensive evaluation of quality maintenance and management, construction methods, and environmental impact, other than various required quality assessments targeting newly developed products, construction methods, and engineering systems which are not covered by any technical standards. Performance evaluation tests. Building materials and components require performance evaluation and type approval according to various regulations, including the Building Standards Law. We at Central Test Laboratory conduct performance evaluation tests in collaboration with the Quality Assessment Headquarters to complete such tests. In addition, we at the Japan Testing Center for Construction Materials also carry out JIS Mark certification of products and processing technologies in the fields of civil engineering and manufacturing. To fulfill this task, fair and impartial quality tests by a third party are required. The Central Test Laboratory works in cooperation with the Product Certification Headquarters to conduct tests successfully complete this mission. The Central Test Laboratory has been accomplishing great things for more than half a century. To conclude, here are some messages from our associates. We value our communication with customers and are doing our best to propose new test services that meet their needs. Our job is not just to test according to JIS, academic standards, etc. I believe our strength is that we can respond in a flexible manner to the requirements, backed by our high level of expertise and technical capabilities as professionals. As a third-party testing institution, we continuously accumulate expertise day after day in order to deliver highly reliable and accurate test results. We have cultivated reliable communication with every single one of our customers for more than 50 years. We are extremely proud of that. It is a secure social foundation that can be handed down to the next generation. In order to realize this vital mission, we at the Central Test Laboratory promise to continue to grow with our customers.